today we're going to be working on chapter 5.1, ratios. This is on page 184 in your book, and I'm going to ask you to quickly turn to that because there's a picture that I'm going to reference here in example 1. So, ratios. First, what is a ratio? A ratio is a comparison of two quantities using division. You can write a ratio in 3 ways. However, we pronounce them all the same way. So first we have here 5 to 7 using the colon, 5 to 7 using the word, and 5 to 7 written in a fraction form. Algebraically, that would be like comparing A to B, and A to B. So example 1 is going to reference the piano at the top of the page that is showing inside the red box 5 black keys, 7 white keys, making a total of 12 keys. So example 1 wants to write a ratio of the number of black keys to the number of all of the keys shown in that red box. So the quantity that is written first in your ratio is always going to go first. And I know that there are 5 black keys, and there are a total of 12 keys altogether. So the 3 ways that I can write my ratio are 5 to 12, 5 to 12 using the word, and 5 to 12 using the fraction. If it does not specifically tell you which way to write the ratio, you can write them in any way. I would say that the most common is probably going to be in the division form because, as you'll see in example 2, that's the easiest to make equivalent ratios from. So, what is an equivalent ratio? You can think of an equivalent ratio like an equivalent fraction because it really looks like a fraction and it acts the same way also. So an equivalent ratio are 2 ratios that name the same number. So for example, 1/2 and 2/4 are equivalent ratios. They are equivalent fractions. So example 2 wants an equivalent fraction for 4/5. Well, 4 and 5 do not have any common factors, so I can't divide and simplify the ratio, but I can multiply. And whenever we reduce or simplify fractions, we divide by a common numerator and denominator. We do the same thing when we are increasing the ratio or fraction, and we multiply straight across. So 4/5 is equal to 8/10. Now this number can be replaced with any fraction as long as it is equivalent to 1. 3/3, 5/5, 9/9, 13/13. It doesn't matter as long as the numerator and the denominator are the same. So how can we apply this to a real life problem? Well, let's take a look at example 3. Number 3 asks to write the ratio 2 yards to 20 feet. So I'm going to rewrite this as a fraction. However, we have a slight problem in that our units don't match. So in order to make the match, I need to convert my yards to feet. Well, there are 3 feet in a yard. I have 2 yards times 3 feet per yard equals 6 feet. So I'm going to rewrite my ratio. 6 feet to 20 feet. But just like a fraction, I want that in simplest form. So I'm going to divide by the greatest common factor and My answer is 3 to 10, or 3 feet to 10 feet. All right, example 4. An official U.S. flag has a length to width ratio of 19 to 10. The largest U.S. flag measures 505 feet, big flag, by 255 feet. Is the largest flag an official flag? Are these equal? Are they equivalent ratios? Well, the easiest way at this point is to convert them into decimals. 19 tenths is 1.9. 505 over 255 is 1.98. So no, they are not equivalent. It is not an official flag. Okay, that's it for examples. Please complete your quick checks and CYU, and we will go over this the next time I see you.